Hey all, so in this video I'll be going over the 2023 Maths Exam 2 and we'll be going over the section B. So without further ado, let's get started. Alright, so our f of x is given and the graph is shown. State the coordinates of all axial intercepts of f. Very well, so before we do anything, let's quickly define the function in CAD. So define f of x is equals to x times x minus 2 times x plus 1. Okay, just making sure I've defined it correctly. I have. And of course, to find the intercepts, we'll just do f of x is equals to 0. Okay. And so our intercepts are going to be -1, 0, 0, and 0, and lastly, 2 and 0. Okay, find the coordinates of the stationary points of f. Very well, so we have to differentiate and then set it equals to 0 to get the stationary points. So define df of x is equals to many for 1. Okay, and now we have to solve for df of x is equals to 0. There we go. So these are our x coordinates of the turning point. We have to substitute these back into the actual function to get the y coordinate. So let's do that. So f of x is equals to, this sign, including, given, not including. Okay, there you go. So this is coordinate number 1, and let's do the same for coordinate number 2. There we go. So these are our stationary points. Okay, so just as a working out step, we can say that we have to set derivative of f is equals to 0. And so then we will get our points to be minus square root of 7 take away 1 on 3, comma 2 times 7 root 7 minus 10 or 27. Okay, and then the other one would be root 7 plus 1 on 3, and it will be minus 2 times 7 root 7 plus 10 or 27. Okay, so yeah. Okay, so g of x is going to be x minus 2. Find all the values of x for which f of x is equals to g of x. Very well, so let's define g of x equals to x minus 2 and solve f of x is equals to g of x. Okay, so we get our x coordinates to be x is equals to minus square root of 5 plus 1 on 2. Then we have x is equals to root 5 take away 1 on 2. And then we have x is equals to 2. Okay, and that's that. So write down an expression using definite integrals that gives the area of the regions bounded by f and g. Okay, so let's plot the graph first to see how it looks. That, and we have g of x. Okay, so we already have the intersection points that we found earlier on, and we just have to set up the integral. So as you can see that from this intersection point till here, f of x will be greater than g of x, and then from this intersection point to here, g of x will be greater than the f of x. So we have to set up our integral accordingly. So let's do that real quick. Okay, so our integral would be negative root 5 take away 1 on 2 to root 5 take away 1 on 2. And in this interval, f of x is greater than g of x. So it will be like that, dx, and plus, it will be from root 5 take away 1 on 2 all the way to x equals to 2. And in this interval, g of x is higher or greater. So we'll have g of x minus f of x dx. Okay, so this is your integral set. Alright, so hence find the total area of the regions bounded by f and g correct to 2 decimal places. Okay, so one thing, it is asking us to find the area in 2 decimal places, not exact form. So we can actually just use the technology here rather than typing out the integral and then solving it. So all you can do is menu 6 and we'll go to bounded area. We go from here all the way to here. And as you can see that this is going to be our, this is going to be our bounded region, bounded area. Okay, so the total area. All right, now If they ask for exact area, you definitely have to type out the integral and get the exact area that way. But if they're just looking for, up to 2 decimal places or a few decimal places, this can also be another way without typing out the whole integral, which may take a bit more time. So the total area we get is 5.95. Okay, hopefully this made sense. So let h of x be this, where h of x is equals to f of x plus k. Find all possible values of a and b. Okay, so in that case, let's draw the graph of f of x first. Okay, so we have something like that. Okay, maybe not like that, but maybe like it's going all the way to origin. So something like that, for example. Okay, now what is this k doing exactly? So I'm going to say that this is our f of x. Now what is this k doing? So k is basically responsible for translating the graph up and down. Well, the whole graph, not just that bit. So up and down like that, okay? Now we have to find the values of a and b such that we get our f of x to be in this form over here. Now, I don't know if you know, but when you have a form like this, how it's represented in h of x, our graph would usually look something like this, basically, where this will be our b and this will be our a. I mean, just as a rough diagram, okay? So a is definitely going to be like, yeah, okay? So this is going to be our b and this is going to be our a. Or alternative could be, oh, it also could be like this. So now b is going to be this one. So this term over here is going to represent the shape which involves an x-intercept like this, essentially. Does that make sense? So what they are basically asking us is, using the values of k, we have to translate the graph up and down to match the shape. Now, if we notice, if I move this graph up by a certain unit, we can achieve this shape over here, right? As you can see, it matches this requirement over here. Okay, so how much did I move the graph up by? That's the question. Now, remember, we calculated our no, not this one. We calculated this values over here, right? So we know the y values of the turning point as well. And if you're talking about this turning point over here, then we are looking at this y value over here, right? Does that make sense? So if I were to move the graph, that particular value up, I will get it in the shape like this. Does that make sense? So what we can do here is we can say that, let me just make a partition. So when k is equals to, what is it? 2 times 7 root 7 plus 10 divided by 27. Now remember that there won't be a negative sign in front of this because we are translating up, okay? The y coordinate here is basically negative of this, but since we are moving the graph by that much units up, we have to take in the positive. So k is going to be positive. Does that make sense? Okay? And now what we have to do is simply, we have to simply substitute. We have to solve for this, substituting k is equals to this whole thing here. So we'll get the x-intercepts, right? And then we can figure out which one is A and which one is B, respectively. Okay, hopefully all of this made sense. So let us get back to the calculator and we'll do f of x plus k, given that k is equals to this value, but there won't be any negatives. Okay, now we'll solve. Is equals to 0. Okay, so we get these two x-intercepts. Actually, let me see if I can factor, if that makes my life easier. Okay, not really. It doesn't give me in that form, but that's okay. So from these two values over here, which one is our b and which one is our a? So far, these two are our x-intercepts. So we have the x-intercepts, okay? Now we have to figure out which one is a and which one is b. So our value of b is going to be this one over here. The reason being that, if I come back to my iPad, we are dealing with the positive x coordinate. So that means we are going to have this as our value of b, because that is the form over here, required form, right? So from here, we can get b is equals to square root of 7 plus 1 on 3, and our a at that time will be minus of 2 root 7 take away 1 all over 3. Okay, so that is one set of possible values for a and b. Now we will do something similar for the other stationary points. We can't just leave it here, because if I were to translate the graph by some units down, we can achieve this form again, right? So again, we do know the y coordinate of this turning point over here. So in this case, we have to say when k is equals to, and we have to say how much units do we have to move the graph down by? We have to move it down by this many units over here, right? Because that is the turning point that we are taking into account now. So we will have minus 2, 7 root 7, was it plus or minus 10? Minus 10 over 27. Okay? And now again, we have to do the same thing. F of x plus k equals to 0 to get the x-intercepts, given that k is this value over here. 7 root 7 take away 10 all over 27. And then from here, we can obtain our values of a and b. Okay, so let's do that. All right, so we need to do the same thing over here, except this will be minus, and this will be minus as well. We will solve. That is equals to 0. Okay. Now again, which one is b and which one is a? Very well. So in this scenario, in this case, we are talking about the x coordinate, which is going to be less than 0. So our b is going to be here, this one over here. Okay, and our a value is going to be this one over here. So we can say b is equals to minus of square root 7 minus 1 all over 3, and our a is equals to 2 root 7 plus 1 all over 3. Okay, so these are going to be our answer for these questions, this question over here. All right, hopefully this made sense. Okay. All right, so let's go to the next page. Okay, question number 2. The following diagram represents an observation wheel. With its center at point P, passengers are seated in pods which are carried around as the wheel turns. The wheel moves anti-clockwise with constant speed and completes one full rotation every 30 minutes. Okay, so every 30 minutes, that is a period of this wheel essentially. When a pod is at the lowest point of the wheel, point A, it is 15 meters above the ground. The wheel has a radius of 60 meters. Okay. Consider the function h of t, and for some b and c value that belongs to r, which models the height above the ground of a pod originally situated at point A after time t minutes. So show that b is equals to pi on 15 and c equals to 75. Okay, so we know that to calculate period, we have to do 2 pi on b. Well, it will be n, but since we have b here, okay. And what else do we know about period? We know the period is going to be 30 as listed in the question here, just here. Okay. So solving for this should hopefully give us the answer. So our b is going to be 2 pi on 30, which would reduce to pi on 15 as required. Now, in terms of finding c, so we do know that at t equals to 0, or the initial point of this wheel is going to be at point A, right? And we do know that point A is 15 meters above the ground. So we can say that h of 0 is going to be 15, right? So we can do minus 60 cosine of 0 plus c equals to 15. Now we do know that cosine of 0 is going to be 1, so minus 60 plus c equals to 15, and c is going to be 75. Okay, so as required, we have shown both of the things. Okay. Find the average height of a pod on the wheel as it travels from point A to point B. Give your answer in meters, correct your 2 decimal places. So we are going from point A all the way to point B. Okay. Now first we have to find out how much time it would take to go from point A to point B. So we know that one full rotation takes 30 minutes. So that means to travel from this point over here all the way to this point over here should take 15 minutes, right? And that means to go from A to B should be half of 15, which is 7.5. Okay. So basically, all we are going to be doing is to find the average value. So we'll have 1 on 7.5 integral from 0 to 7.5 h of t and dt, which is equals to. So let us do this on our calculator, and I'll just include a new problem. So insert a new problem, add calculator. Okay, so let me see the function and define it. So define h of t is equals to minus 60 times cosine of pi on 15t, 15 times t, plus 75. Okay. And now we have to find the average value. So we'll do 1 divided by 7.5. And then we do times by menu for 3 all the way from 0 to 7.5 h of t dt. So we get 36.80. So let's write that down. So we have 36.80. Okay. So meters, of course. Okay. All right. So find the average rate of change in meters per minute of the height of a pod on the wheel as it travels from point A to point B. Okay, so if you're talking about average rate of change, you have to apply the gradient formula. So all we have to do is we'll have to do h of 7.5 take away h of 0 over 7.5 take away 0. So this is basically y2 minus y1 over x2 minus x1. Okay, just the gradient formula here, nothing fancy. So if we calculate that, so we'll have h of 7.5 take away h of 0. And then we'll have 7.5 take away 0. So that is going to give us 8 meters per minute. So 8 meters per minute. Okay. All right. After 15 minutes, the wheel stops moving and remains stationary for 5 minutes. Okay. After this, it continues moving at double its previous speed for another 7.5 minutes. The height above the ground of a pod that was initially point A after 2 minutes can be modeled by the piecewise function w. State the values of k and m. Okay, so the value of k is simply going to be h of 15, right? Okay, so we'll have k is equals to, will be h of 15, so that'll be 135. Okay, and now to find the value of m, we know that it is going to move double its previous speed for another 7.5 minutes. So basically, from 0 to 15, it follows h of t. From 15 to 20, which is another 5 minutes, it remains stationary. Okay, so that is the k value. And now, third region would be this part over here. And since we are moving double the previous speed, our m would simply be 2. Okay? Hopefully that made sense. So find all possible values of n. Okay, what do we know about finding this over here? Well, one thing we can determine is that w of 20 has to be 135, right? Because it's stationary from 15 all the way to 20, right? So all we gotta do is to solve h of our m is 2, so h of 2 times 20 plus n has to equals to 135. So h of 40 plus n equals to 135. So then we just have to solve for the value of n, and since we are finding all possible values, this is going to be a general solution. Okay, so solve h of 40 plus n equals to 135. Okay, so we get n is equals to 5 times 6 z, or maybe not z, a plus 1. Okay, so if we expand this, we will get 30 a plus 5, and then here a is going to be all integers. Okay, hopefully this made sense. So let's move to the next page. So sketch the graph of the piecewise function w on the axis below, showing the coordinates of the end points. Okay, so in that case, what we can do is first define the piecewise function. So we'll have define w of t, and then we'll go here. Okay, and then the first section was h of t, which is from, well, we'll have to do h of x because else it's going to ask me to add a slider. H of x from 0 less than or equals to x less than 15. Then we have 135, which is the value of k, and that was from 15 less than or equals to x less than 20. And then we have h of 40 plus, I guess since we found the general solution to be 30a plus 5, and if we take a as 1, just for an integer to substitute our point in, we will get 35. So 40 plus 35. Does that make sense? Because we had h of 2t plus n, so we figured that our t was, oh no, actually, it will be 2x, not 2 times x plus 35. And it should be 20 less than or equals to x less than or equals to 27.5. If I do enter, and let's plot that. W of x, menu for A. Okay, menu 4 and 4. So if I zoom out, there we go. So this is going to be our shape of the graph. Okay. So let us plot that. So of course we have to first find the initial value of the graph. So what we can do is we can say W of 0. We'll get 15. Okay, so it will start from here. And then we know between 15 and 20, it's going to be 135. So let's label that as well. So that's 130, 135, and 15. So somewhere around here and here. And then of course we find the n value, which is 27.5, which is also 15. So 26, 27.5, and it will be somewhere here. So this is going to be our graph, okay, like the outline of our graph. So let us plot this now. And just for the reference, what I'm going to do to get the scaling right is I'm going to get another arbitrary point between 0 and 15 to ensure that my scaling is correct. So let's say I substitute in W of 10, right? W of 10, 105. Okay. So that'll be 100, 105 would be somewhere around here. Okay. And now we will just revert back to the shape of the graph and see how it looks. Okay, so it goes like, no, like that. Okay, and now from here it has a straight line like so. Okay, and just to make sure it's falling smoothly. Okay, and now from here all the way to 27.5, let's substitute in W of 25 to identify the scale so that we don't get it wrong. So W of 25, 45. Okay, so 25, you'll be 40, 45, so somewhere around here. Okay, so our shape, it's going to go from here all the way to here, like that, something like that. Okay, and what are they asking us to label? So label the coordinates of the end points. So this one I can remove now, I don't need it. Same here. Okay, so endpoints, this one is going to be including 0 and 15. And this one is also going to be including 27.5 and 15. They don't ask us to label this, but I'm just going to do it in case. It's always good to do it. Better to be safe than sorry. Okay, and that's the graph done. Hopefully this made sense. Okay, so question number 3. Consider the function this, state the value of this. Okay, so we had to add a new problem, insert a new problem. All right, so define g of x is equals to 2 to the power of x plus 5. Okay, and then we'll do, not 9, we have to do the limits. Limit, then we have x negative infinity to gx be 5. Okay, okay, the derivative of g of x can be expressed in the form of this. Find the real number k. Okay, so we are finding the derivative, so define dg of x is equals to menu for 1 g of x, and we'll meant to type out dg of x. Okay, so as you can see that our form that is required is k times 2 to the power of x, and our answer we got was ln2 times 2 to the x, so our k value is going to be this. So k is equals to natural log of 2. Okay, let a be a real number. Find in terms of a the equation of the tangent to g at point a and ga. Very well, we can just use the tangent line function. So menu for 9, g of x comma x equals to a. Okay, this is a horrendous looking equation, but yeah. So y is equals to 2 to the power of a times by natural log of 2 x, take away brackets a natural log of 2 minus 1 times by 2 to the power of a plus 5. Okay, hence or otherwise find the equation of the tangent to g that passes through the origin, correct to 3 decimal places. Okay, so we know that the general form of equation is basically going to be this, paste. Okay, and since it's passing through the origin, we also know that it's going to pass through 0 and 0. Okay, so then if I were to solve for 2a log base 2x minus a times log base 2, take away 1, 2 to the power of a plus 5 equals to 0, substitute x equals to 0. We will get the value of a, for which that is true, right? And then we'll just substitute the value of a back into this equation over here to obtain the actual equation. All right, so solve. Okay, let me actually first substitute in x equals to 0, and then we'll do solve that is equals to 0 comma a. So there you go. So our a value is equals to 2.62 roughly. And if I were to now substitute the a value back in here, there you go. So this is going to be our equation of the tangent, like the actual tangent that we are meant to find. Now, this over here is just basically 0 because it's passing to the origin and it's a very small number, so we don't have to take into account that. So what we can do is we can write that A is equals to 2.618, and then we substituted that back. So 2a times log base 2 of x, take away a log base 2 minus 1, 2 to the power of a plus 5, given that a is equals to 2.618. And so our tangent is equals to y equals to 3 decimal places. So it'll be 4.255x. Okay, that's done. Hopefully this made sense. Alright, so find the coordinates of the point of inflection. Let h of x be this. Find the coordinates of the point of inflection correct to 2 decimal places. Okay, so in that case, let's first define h of x. So define h of x is equals to 2 to the power of x, take away x squared, right? And then we have to differentiate it twice to obtain the point of inflection. So we'll do menu for 1. Well, let me just define it as well while I'm at it. So define dh of x is equals to menu for 1 h of x. Okay, and now we'll do define h of x equals to menu for 1 dh of x. Okay, so solve. h of x is equals to 0, comma x. So this is our x coordinate, and now if I were to substitute that back into our h of x to get the y coordinate, this is our y coordinate. Okay, let us write this down. So we have to write it correct to 2 decimal places. So we will have 2.06, comma, negative 0.07. Find the largest interval of x values for which h is strictly decreasing. Give your answer correct to 2 decimal places. Okay, so in that case, let us quickly sketch the graph of this. So h of x can be seen to be decreasing in this region over here. And since we are asked for strictly decreasing, we have to include square bracket. And since also we are asked to find it to correct to 2 decimal places, we can just analyze the graph for maximum and minimum to obtain our x coordinates. So menu 6, and we'll do maximum first here. Okay, and then we'll do minimum, menu 6, 2. There we go. Okay, so as you can see, that h of x is strictly decreasing between these 2 points over here, which are going to be our turning point, or local maximum and local minimum. Okay, and these are our x values. So since we are asked to find it to 2 decimal places, our range our interval for x values would be that x belongs to square bracket of 0.49, comma 3.21. Now remember, because it is asking for strictly decreasing, we have to include square brackets, okay? Not the round brackets. Okay, so apply Newton's method with an initial estimate of x0 equals to 0 to find an approximate x-intercept of h. Write the estimates x1, x2, and x3 in the table shown below. Correct to 3 decimal places. Okay, so in that case, let's go back to the calc. So we have, actually no, so we have x0, right? And our formula to calculate the x1 would be xn plus 1, so 0 plus 1 is equals to x of 0, take away, not f, but h of 0 divided by derivative of h of 0, right? That is going to give us our x of x1, basically, okay? So let us calculate that. So for this one over here, basically that is just going to become 0 because x0 is going to be 0. So let's calculate this on our calculator. So we will have 0 take away h of 0 divided by dh of 0. Okay, so we get x1 to be negative 1.4427. Well, this is 3 decimal places, so 1.443. Okay, now the next number, x2, it will be x1 plus 1, which is equals to x1 take away h of x1 over derivative of h of x1. Okay? So we will have minus take away h of this and then dh of the whole thing as well. So just that one over here. Oh, Control C, Control V, there we go. Okay, so we get negative 0.897. Okay, and then lastly we do the same exact thing for x3. So it will be x2 plus 1 equals x2, take away h of x2 divided by h derivative of x2. Okay, so we will have that over here, take away h of this whole thing and dh of, we just copy the whole thing, Control V, negative 0.773. Okay, so that is going to be your table. That is all the answers you need for the table. All right. So for the function h, explain why a solution to the equation this should not be used as an initial estimate x0 in the Newton's method. Very well. Let's have a look at the derivative of h of x first. Okay, there you go. So as you can see that the function that is given is the derivative function. And they're asking us why we should not set it equals to 0 for the Newton's method. Well, what happens if we set the derivative to equal to 0? We will get a straight horizontal line. And moreover, the entire Newton's method formula would not be defined because the denominator over here would just become 0, making the whole thing undefined, right? So that's why we can't use it. So let's put that in words. So the equation log base e of 2 times by 2 to the x minus 2x equals to 0 is the same as setting h dash of x is equals to 0, right? And since Newton's method is given by xn plus 1 equals to xn take away h of xn over derivative of xn, having or maybe setting h dash of x equals to 0 would make it undefined. And hence cannot use it. And hence cannot be used. Okay? There is a positive real number n for which the function f of x equals to this has a local minimum on the x-axis. Find the value of n. Okay, let us define f of x, not g of x, f of x is equals to n to the power of x take away x to the power of n. Okay. So for it to have a local minimum on the x-axis, there is two things that needs to be true. Number one being that the derivative of f of x has to equal to 0 and f of x have to be equal to 0. So if these two occur at the same time, we will get a local minimum at the x-axis, right? So if I were to differentiate this menu for 1, f of x, maybe I should define it as well. Df of x equals to, okay, and let's see if we can get an answer. If not, we'll just solve this graphically. We don't have to differentiate, we have to do solve, and then we'll do this over here. We'll have f of x equals to 0, and then we also know that df of x equals to 0, comma x, comma n. Let's see if we can get an answer. Okay, unfortunately not. So in that case, what I'll do is I'll just plot this and we'll see how we go from there. Okay. All right, so, okay. I want the local minimum on the x-axis. So between 2 and 3, it seems to be getting closer. And as soon as I hit 4, it goes terribly wrong. So what I'll do is I'll maybe set my limits to 2 and 3. Wait, what? 2 and 3. And we'll do 2. Okay, let's see. Yeah, as you can see, oh, okay, 2.7, 2.8, and 2.9 again, we can see it's not at the x-axis. 2.8, 2.7 seems to be the answer here. But actually, could it be E? N equals to E? Because E is also 2.71, right? Okay, let's put N equals to E. Okay, I think that's it. So if I do menu 4, well, menu 6, well, menu 6, and then I'll do I'll do minimum. Yeah, okay, there you go. Yeah, okay. It is indeed going to occur at N equals to E. Okay, very well. So we can write our understanding that f of x is equals to 0. Derivative of f of x is also equal to 0. And then we can just say N equals to E. I mean, even though we didn't quite use that, but since this is a 2-marker question, they do expect a little bit of working out. Okay? All right, question number 4. So a manufacturer produces tennis balls. The diameter of the tennis balls is normally distributed random variable d, which has a mean of 6.7 centimeters, standard deviation of 0.1. Find probability that d is greater than 6.8, correct to 4 decimal places. Okay, very well. So in that case, let me insert a new document. And you're to use normal distribution here. So menu 552. Our lower bound is 6.8. Upper bound is infinity. Mean is 6.7. Standard deviation is 0.1. Okay, so our probability is going to be 0.15. It's 4 decimal places, so 0.1587. Find the minimum diameter of the tennis ball that is larger than 90% of all tennis balls produced. Give your answer in centimeters, correct to 2 decimal places. So this is going to be inverse normal question. So basically, we have a bell curve over here, and we know that the probability or the area over here is going to be 90%. This is going to be 0.9, and we have to find this actual value over here. That's what the question is asking us to do. So all we gotta do is use inverse normal for this question. So we'll do menu 553, area we calculate to be, or we already have it to be 0.9, mean is 6.7, standard deviation is 0.1. So answer is 6.83 to 2 decimal places. Okay. Tennis balls are packed and sold in cylindrical containers. A tennis ball can fit through the opening at the top of the container if its diameter is smaller than 6.95. So find the probability that a random selected tennis ball can fit through the opening at the top of the container. So again, we are asked to find the probability. So we have to use menu 552, the normal CDF. But this time we are given the upper bound, which is 6.95. Mean doesn't change. Standard deviation also doesn't change. So our probability would be 0.99, well, 4 decimal places, so 0.9938. In a random section of 4 tennis balls, find the probability that at least 3 tennis balls can fit through the opening at the top of the container. Give your answer correct to 4 decimal places. Okay, so in these sort of questions, well, this is a binomial question, okay? So first, what I like to do is set a random variable. So I'm going to say let x denote the number of balls that fit through the opening What this does is this makes it very clear to examiner that what x exactly is, because sometimes if you have a lot of variables in your question and you have to introduce a new one, it can get a bit tricky. So it's always best to just write this down and, just to be safe. And now we can use x is binomial, and our notation for binomial is n comma p. So our number of trials is 4. And our probability of success is 0.9938. And what are we finding? Probability that x is greater than or equals to 3. Alright, so now let us find this on our calculator. So menu 55b. So number of trials is 4. Probability of success is 0.9938. Okay, then lower bound is going to be 3. Upper bound is 4. Okay, so it's going to be roughly 0.9998. But just to be sure, what I'm going to do, I'm going to substitute the actual value. Okay, same thing. So well, we have 4 decimal places, so 0.9998 is going to be our answer. Okay? Alright. A tennis ball is classed as A grade if its diameter is between 6.54 and 6.86. Otherwise, it is classed as grade B. Given that a tennis ball can fit through the opening at the top of the diameter, find the probability that it is classed as grade A. So we are basically finding probability that it is classed as grade A, which is when the diameter is between this. So probability that 6.54 less than D less than 6.86, given that it is fitting inside the top of the container. So given that diameter is less than, what was the value? 6.95. 6.95. Does that make sense? Okay. So if it can fit in the container, the diameter has to be less than 6.95, as we already saw in the question earlier on, and it has to also be of grade A. So when does the grade A occur? Well, if the diameter of the ball is between this, then it is grade A. So we are basically finding this over here, right? And in that case, we will get probability of 6.54 less than D less than 6.86 divided by probability of D being less than 6.95. Okay, so what we can do is go back to the calculator, and now if I do 6.54 and our upper bound is going to be 6.86. Okay, so we have that, and now we will divide that by probability of it being less than 6.95, which is what we calculated just over here. So we have to divide it by this, and that is going to be our answer. So we can write this as 0.8904 divided by 0.99 what is it, 9938, which is equals to 0.895. 4 decimal places, 60, 8960. Wait, no, 8560. Oh no, never mind. 8960, my bad. Was looking at a lot of 5s around this, so I just got confused. Okay, 8960, yes, that is the final answer. Okay, the manufacturer would like to improve process to ensure that more than 99% of all tennis balls are produced as class grade A. Assuming that the mean diameter of the tennis ball remains the same, find the required standard deviation of the diameter in centimeters, correct to 2 decimal places. Alright, so in that case, let's draw a bell curve. Let's see what's exactly happening. Well, that's a good try. I'll do one more. Well, I'll just extend one last try. Whatever, this will do. Okay, good enough. Alright, so we know that our mean is 6.7, and for it to be in class or grade A, the diameter has to be between what? 6.54, right? 6.54 and 6.86. And it ensures to more than 99%. So this shaded region over here, this region has to cover 0.99. So the probability of falling between this region has to be greater than 0.99, greater than or at least, like at least 0.99. Okay, so that means the remaining section would be 0.005 and 0.005, right? So essentially what we are finding is probability of diameter being less than 6.54 has to be less than or equals to 0.05 or 0.005, and probability of D being greater than 6.86 has to be less than or equals to 0.005, right? And if I were to take this into a standard normal form, we will get probability of Z less than 6.54 take away 6.7 over standard deviation has to be less than 0.005, and probability that Z is greater than 6.86 take away 6.7 over standard deviation has to be less than or equal to 0.005, I think, right? Okay, hopefully that kind of makes sense. I'm just basing all of these equations off from this diagram over here. So now what we'll do is we'll calculate the standard normal, or like we'll use the inverse normal to get the actual standard normal values. So we'll go menu 553. Oh, menu 553. Okay, the area is going to be 0.005. Standard normal, so mean is 0, standard deviation is 1. So this is our value that we get. Okay, so let's write it down. So 6.54 take away 6.7 all over that has to be less than or equals to minus 2.576. Okay, and then the other value would be 6.86 take away 6.7 over standard deviation has to be greater than or equals to, let's calculate the greater than or equals to. It's going to be the same, except this time it's going to be 995, because remember that we are doing left tail calculator, like CAS calculator is left tailed, so we have 0.995, and it's going to be the positive of that, so 2.576. Okay, so basically let me give you a visual of what this is. So say for example that on a standard normal curve, we erase all of this. Okay, on a standard normal curve, let's say that this is our mean, right? So 6.7. We want standard deviation such that the value that we get, like after standardizing the data like this falls under, like this is 0, sorry. Yeah, okay. So we are basically finding a value such that, like the standard deviation such that if I were to that probability of it being less than this value, so 2.576, negative of that, this value over here has to be equals to 0.005, and same on the other side. That's what we are finding. Okay, and now by using these two inequalities and equations, we can also calculate the standard deviation. Okay, hopefully this made sense. All right, so we will have 6.54 take away 6.7 divided by x has to be less than or equals to the negative of that. Okay, so this is our range, first range, and let's calculate the second range as well. It should be the exact same, and this time it should be greater than or equals to, there we go. So it's the exact same basically. So as long as your standard deviation is between 0 all the way to 0.06 inclusive, all of this is correct, but make sure that it is two decimal places. So you can write 0.01, 0.02, so on and so forth until 0.06. Okay, any of these should be correct. Okay, hopefully this made sense to you. Okay. Alright, an inspector takes a random sample of 32 tennis balls from the manufacturer and determines a confidence interval for the population proportion of grade A balls produced. The confidence interval is this, correct to 4 decimal places. Find the level of confidence that the population proportion of grade A ball is within the interval as a percentage, correct to the nearest integer. Okay, so this time we are given the range of confidence interval. So from that we can determine the p hat value, and all we gotta then do is to substitute the information in the formula, and then we'll be done. Okay, so how do I calculate the p hat value? Well, it's going to be 0.7382 plus 0.9493 divided by 2. This is how we get the p hat value. So let's calculate that. So it will be 0.7382 plus 0.9493 divided by 2. So we get 0.84375. Okay, now we can just apply the standard deviation, not standard deviation, we can apply the confidence interval formula, because it will be like p hat take away z times by p hat times 1 minus p hat on n, and this will give us the lower range of the confidence interval. So in this case we'll have 0.7382. So we just have to substitute in the values because we know what p hat is, we know what n is. The only missing variable is z. Okay, so let us calculate that. So 0.84375 take away z, 0.84375 times by 1 minus 0.84375 divided by, what is our sample size? It's going to be 32. And this has to equal 0.7382, the lower bound of the confidence interval. And now if we solve for the value of z, we can progress in this question. So that take away x or maybe z times square root of, actually let me just write the whole square root. It's going to be a lot of brackets. Okay, so it will be that times by 1 minus that divided by 32. I forgot to write solve. Solve at the end. There we go. We have that as 0.7382, right? Yep, comma z. Okay, so as you can see that our z is going to be 1.6443. Okay, and the other side is going to be the exact same. So we have to now find this over here, probability of minus 1.6443 less than z less than 1.6443. Oh well, it's going to be 3 times. There we go. 443. 443. And that's how we find the confidence interval. So this will basically give us the probability, and after that we just have to convert it to the percentage to get the confidence interval. Okay, all right, so we'll do menu 552. Well, menu 552. Okay, so we have 1.6443. Control A, Control C, Control V. Okay, not copy. 3. We'll do 0 and 1. So roughly it has to be 90%, but just to be sure, I'm just going to substitute in the whole value. Okay. negative, and we'll just do that. Hopefully I can paste it. No, come on, surely I can paste it. That's fine. All right. There you go. Okay, same thing. All right, so this will give us a probability of 0.90. So our confidence interval is going to be 90%. 90% confidence interval, okay? All right. A tennis coach uses both grade A and grade B balls. The serving speed in meters per second of grade A ball is continuous random variable V, okay, with probability density function this. Find the probability that the serving speed of a grade A ball exceeds 50 meters per second. Give your answers correct to 4 decimal places. Okay, so first we have to define the function V, so the function f. So f of V is equals to, what's a piecewise function, so do that. Sine 2. Okay, 1 on 6 times pi times by sine, oh, wrong place, times by sine of square root of V minus 30 over 3, and the domain is 30 less than or equals to V less than or equals to 3 pi squared plus 30. Yeah, this is not in the domain field. All right, Control V. There we go. 0, and yeah, that is all fine. So 1 on 6 pi times sine of this. Okay, that seems about right. All right, and now we have to find the probability that a ball exceeds 50 meters per second. So basically, we are finding integral from 50 all the way to the maximum, which is 3 pi squared plus 30 f of v dv. So that is going to be our answer. So 0.1345, 4 decimal places. Find the exact mean. Find the exact mean serving speed for grade A balls in meters per second. So that would just be 30 to 3 pi squared. Wait, was it 3 pi squared plus 30? V times f of v dv. Okay, so just copy that down. V times that, and this will be 30. So it will be 3 times pi squared plus 4 meters per second. Okay, the serving speed of a grade ball B is given by continuous random variable W with probability density function GW. A transformation maps the graph of F to the graph of G, where GW is equals to A of FW on B. Okay, if the mean serving speed for a grade B ball is 2 pi squared plus 8 meters per second, find the values of A and B. All right, so in that case, first thing we should know is A times B is equals to 1. Now, why do I say that? It's because this relationship is to make sure that probability density function is maintained. Okay? Because A will take care of the A is basically the dilation from the x-axis and B is from the y-axis, right? So basically all of the, regardless of what kind of dilation we apply, the area under the same graph must be 1. So A times B must be 1. So from there we can imply that A is equals to 1 on B, right? And now if I were to draw a graph, like, actually no, so before, like previously, our mean was 3 pi squared on plus 4, like so. And then we did something with the x values. We did something with the x values to make it go. So basically we multiplied by a factor of something. So that factor is going to be b times 3 pi squared 3 times pi squared plus 4 is equals to 2 times by pi squared plus 4. Okay? So basically, we did something with the x values to change it to 2 pi squared plus 4. Basically, we applied the dilation, and b is responsible for that. Okay? So we will have, if we solve for b over here, we will get the value of b. So b has to be 2 pi that on 4 over 3 pi squared plus 4. So this and this would cancel out. So b is going to be 2 on 3. Okay? Alright, let me just move that to my fair working out. And this looks horrible, so let me just do that. So if b is equals to 2 on 3, then a is going to be the flip of that, so 3 on 2. So that is the value of a and b. Hopefully this made sense. This is a very similar question that appeared in 2021 exam as well, like exam 2 of 2021, where they asked something very similar to this. So yeah, just a repeated question, like a concept repeated from that exam. Okay, hopefully this made sense. So let me just quickly reiterate over that. Okay, so this property, hopefully that made sense. So B is responsible for the horizontal dilation and A is responsible for the vertical dilation. So basically, they both have to equal to 1. So whatever we do to A, we have to do reciprocal of that to B in terms of dilation to maintain the PDF property of this function, right? And since B is taking care of the horizontal values, so before, if I were to draw a quick graph, okay, so we had our mean as 3 pi squared plus 4, and then suddenly it then changed. So if I had to copy and paste to 2 pi squared on 4, like 2 pi squared plus 4. So we did something with the horizontal dilation here, and B is responsible for the horizontal dilation, okay? Because B is a dilation factor from the y-axis and A is a dilation factor from the x-axis. Okay, so yeah, hopefully this made sense. So because B is in control of the horizontal dilation, we are going to multiply B times 3 pi squared plus 4 is equals to 2 pi squared plus 4, right? Because that is the horizontal dilation. And then we are just going to solve for B, and whatever we get B, A is going to be the reciprocal of that. And that is exactly what we did. So that is the main rough idea behind this question. Hopefully this makes more sense to you, because these type of questions do make appearances quite a bit. So better to, you know, secure the marks in this while you can. All right. Okay, cool. All right, question number 5. So let f of x equals to this, g of x is equals to that. Okay, create a possible sequence of transformations to map f to g. So we have dilation factor from the x-axis, okay? And then I can also see a reflection in the y-axis. So reflection in the y-axis. And then we are translating, okay, 2 units to the right. Okay, so we have half f of x to begin with, right? And then we did reflection in the y-axis, so we'll have f of minus x, and then we are moving 2 units to the right, so it will become that, and then minus x minus 2, okay? And this would result in f of 2 minus x, which is what we have here. So yes, translation of 2 units right, 2 units to the right, okay? Two functions g1 and g2 are created both within the same rule as g, but with distinct domains, such that g1 is strictly increasing and g2 is strictly decreasing. Give the domain and range for inverse of g1. Okay, so let us create a new document. So insert new problem, add calculator. Let's define functions. So define f of x is equals to e to the power of x plus e to the power of minus x. Okay? All right, and then we have define g of x equals to 1 on 2 times by f of 2 minus x. Okay? All right, and we have g1 is strictly increasing, g2 is strictly decreasing, and we will find the domain and range of the inverse of g1 basically. Okay, let us plot this graph. So g of x. All right, like so. So basically, if I were to plot the inverse, which would be relation g of y equals x, there you go. So this part over here is strictly increasing, okay, and we will find the domain of that. So basically, we are looking, okay. So if we find the turning point, right? Let's find the turning point of g of x first. So menu 6, minimum, this graph, so 2 and 1. Okay? So that means that if x is, so it's a domain for the inverse, like domain for the inverse of g1, so g1 which is strictly increasing is going to be this part over here. Okay, this, not like this part, just the part above. So from this turning point and beyond. So if x is greater than or equals to 1, we can see that inverse of g1 is increasing, strictly increasing, and the range has to be 2 or bigger, so greater than or equals to 2. Okay, so let us write that down. So the domain would be 1 to infinity, and the range would be 2 to infinity. Okay? All right. So let's move on to the next page. Okay, shown below is a graph of g, the inverse of g1 and g2, and the line y equals to x. Okay? The intersection points between the graph y equals to x, y equals to g of x, and the inverses of g1 and g2 are labeled as p and q. Find the coordinates of p and q correct to 2 decimal places. Alright, so if these are going to be our p and q, we can see, well, that was a very weird error. Yeah, just here. So if these are going to be our p and q, we can see that if we find the intersection of y equals to x with g of x, we technically can get p and q right away, rather than having to deal with inverse here at all. So I'm just going to do exactly that. So I'll go to my calculator, solve g of x is equals to x comma x. Okay, so there you go. And our p is going to be 1.27 and 1.27. Y coordinate we do not need to calculate because it's going to be on the line of y equals to x, okay? And our q is equals to 4.09 and 4.09. Find the area of the region bounded by the graphs of g, inverse of g1 and g2. Give your correct answer to 2 decimal places. Okay, now if I were to go back to the graph over here, as you can see, if I were to draw a y equals to x, well, we can see that the area underneath, so the area between y equals to x and this region over here, this part over here, is going to be the same as the area of this region over here, right? So we can basically just do 2 times the area of this region over here, and we can easily obtain that. And since we are asked to calculate the area to 2 decimal places, we can also just simply use our calculator to do that. So bounded area, we'll go with this graph and this graph. I want it from here to here, and then we just have to times that by 2. So Control C, and if you do times that by 2, so that is going to be our area. But just to be safe, I'm also going to write the integral. So menu for 3, and if I do that over here, and then this section over here. And as you can see that in this region over here, y equals to x is greater than y equals to g of x. So it will be x minus g of x dx. Oh, well, we have to times it by 2. My bad. So times that by 2. Okay, as you can see, we get the same answer. All right, so you can do it either ways. If they're just asking for 2 decimal places, you can just simply use the calculator over here to do the trick. But since this question is 2 marks, better if we just show a single step of working out. So area can be calculated by using the integral from 1.27 all the way to 4.09, x minus g of x dx equals to 5.56. Okay? Alright, so let h be this function over here. The turning point of h always lies on the graph of the function y equals to 2 times x to the power of n, where n is an integer. Find the value of n. Okay, so in that case, what I'm going to do, I'm going to define the function h first. So define h of x is equals to 1 on k times by f of k minus x. Okay, so now if I were to plot this, so h of x. All right, so let's move this slider down a bit because we'll have another slider, which is going to be 2 times x to the power of n. Okay, all right, so I'm going to move this slider up. All right, so here, okay, if I were to move, as you can see, if I were to move, like currently, if k is equals to 1, yes, the turning point lies exactly on like n is equals to 3, 4, whatever. But as soon as I move k to a different value, as you can see, it's going further and further down. So that's, okay, what if I go in the negative section? Okay, n equals to 1, that looks pretty promising. So if I move, yeah, there you go. So it's directly on the graph now. So as you can see, it's following the trend. So that's always good. So our n is going to be -1. Okay. But I do wonder if there is another way we can actually solve this by not using not graphically, but rather doing it by using the equation. So if I do del var n, so this is going to be basically deleting the variable defined as n over here. So as soon as I enter this command, our n will be just blank. We have to do the same thing for k. Okay. Okay, now as you can see, both of these are undefined, so we don't have a graph. All right, now what I'm going to do, since this is a matter about turning point, what I'm going to do is try find the turning point of h of x. So if I do menu for one h of x and solve that equals to 0. Okay, so our turning point is going to occur at x equals to k. Okay, and if I were to substitute that back, all right, so there we go. So as you can see, our n was -1. Now, no matter what the value of k is, as long as k is, greater than 0, I mean, not 0, but our domain that is given in the question is k has to be between 0 and infinity, with 0 not excluding, 0 not included. So, as long as k is any value, our turning point will always be at 2 on k. So it's basically saying, it's similar, it's exactly the same as saying 2 over n, basically. And that is basically 2 to the power of n, 2 times n to the power of -1. 2 times n to the power of -1. There you go. So as you can see, we can also do it by using the equations over here, by simply just calculating the turning point over here, and it will tell you exactly the equation and the n value that you need to use to find to meet the condition, basically. So we have two ways. One is to do graphically, and you can also do this method over here. whichever one works. Okay, so our n value is equals to -1. Okay, so let h1 from k all the way to infinity. Oh, and also the domain I was talking about with the k, as you can see, it's from 0 to infinity, with 0 being excluded. Okay, so the rule for inverse of h1 is this: what is the smallest value of k such that h will intersect with the inverse of h1? Give your answer correct to 2 decimal places. Okay, so what I'm gonna first do is let me define h1 of x equals to log base e of k on 2 times x plus 1 on 2 times by the square root of k squared times by x squared minus 4 and all of that plus k. Okay, just making sure I've defined it correctly. Yes, it seems like I have. Okay, now we will find the smallest value of k such that h will intersect with the inverse of h1. The rule for, okay, so the inverse of h1 is this, okay? And we will find the values. Okay, so let's plot both. Okay, I'm gonna remove this window over here completely, and I'll do one more. So we'll plot h1 of x. Yes, we'll make a slider for k. And then we'll do h of x. Okay, we have to find value of k such that these two intersect. Okay, so as soon as I go from 1 to 2, it starts to intersect. Okay, as you can see. What if I go in the negative direction? Okay, so it does both. But since we are only looking at the positive side, as the domain that is specified in the question was from 0 to infinity, with 0 being excluded, we're only going to be looking at the positive side. So I have a feeling that the value is going to be between 1 and 2, right? And how can we solve this? Well, if I were to draw a y equals to x, right? And now if I were to move the slider like that. So as you can see that both of these actually intersect, like at least one point is basically on y equals to x. So we have to find the value of a such that, find the value of k such that the graph would basically be tangent to the y equals to x. Okay, so for that, what I'm going to do is I'm going to find the value, I'm going to find a tangent line of h of x. So I'll do menu for 9, h of x, x equals to a. Okay, and here we have this massive equation in terms of a, so at any given point. Now, what I want to do is I want to find the value of a or k, whatever, such that this graph over here is tangent to this line over here. So what I'm going to do is I'm going to set two equations over here. So solve, and I'm going to say that is equals to 1, right? Equals to 1. And the whole of this section over here is equals to 0. Comma a. Oh, that is false. Why is that false? Okay. What if I do k? Let's do k. Oh, k is defined actually. Okay, wait, let me try deleting the value of k. So menu 1, 3, and if I do that, now if I do this, okay, now I get it in terms of k. So if I now do the same thing, so I'll copy this, do that, and I'll take this one away. That is equals to 1, and the whole thing over here is equals to 0, comma a, comma k. Okay, there you go. So I do get an equation, or I do get some values over here. So I guess because k was defined, it was messing the whole thing up. Okay. Yeah, but k is negative though. We don't have to care about a over here. We are just simply looking for the value of k, right? Okay, very well. What I'm going to do, I'm going to copy this and just take it here. Okay, it is tangent right now, like that. What if I do positive of this? Ah, there you go. Okay, fantastic. So yeah, k is equals to 1.27. I don't know why it was giving me negative value. Maybe if I set a condition, I have to undefine the value of k again. So menu 1, 3, k, and if I now say that k has to be greater than 0, okay, now it doesn't give me any answer. Strange. Okay. What if I do a greater than 0 and k greater than 0? It doesn't give me any answer, but not to worry, it does make sense because due to symmetry across y equals to x, right? It does make sense to be able to use the positive value and still get it right. So if I just do that, if I just calculate that, yeah, there you go. So when k is 1.27, these two will exactly intersect once. And we can also test it. If I can, maybe the menu 6 intersection, we'll do graph of this, graph of that. There you go. Only one intersection, and that too exactly on y equals to x, because as you can see, x and y coordinates are the same. Okay, so that verifies everything. Okay, so hopefully, yeah, that made sense. So our k value, well, our k is equals to 1.27. It is possible for the graphs of h and the inverse of h1 to intersect twice. This occurs when k is equals to 5. Find the area of the region bounded by the graph of h and the inverse of h1 when k equals to 5. Give your answer correct to 2 decimal places. Okay, let's set k equals to 5 and see what the picture looks like. All right, if I were to adjust that. So we are finding the area between inverse of h1, so this graph, and h of x itself. So as you can see that, let me remove this line, let me remove this point as well. Okay, so as you can see that between these two areas of intersection, as you can see, the inverse of h1 is definitely greater than h of x. So we do know which order to put our integration in. And now all we have to do is to find the intersection points first. Okay. So we can do, because we already have defined k is equals to 5, so we can just do h1 of x equals to h of x, comma x. Okay, so there you go. So these are the intersection points. So let me just write that down real quick. So first we did that is equals to h of x, given that k is equals to 5, and we got x is equals to 1.4509 and x is equals to 8.7816. Okay, and these are our intersection points, and as you can see that between this region, h1, like the inverse of h1 is greater than the h of x, so therefore our integral would be from 1.4509 all the way to 8.7816. h1 inverse of x, take away h of x dx. And since we are again asked to find it to 2 decimal places, we can simply just use the area bounded by analyzing and bound area, intersection here and here. And as you can see, that gives us the answer, which is going to be 43.91. So that is going to be the answer for this question over here. Now, of course, you can also type the whole integral out, but I feel like this way is a bit more quicker, saves you a lot of time, especially if you have to type like weird thirds and weird decimal places. This would definitely help you save more time. Okay, so moving on. Oh, that's it. Well, very well. So hopefully you guys learned something from this video, and hopefully you guys found it helpful. And thank you for watching, and I'll see you in the next video. Bye-bye.